I wanted to record myself doing a little bit of refactoring on the recent code changes in Y0 for the ioSCM data structures. So specifically, we're looking at this function, check ancestors are prior to non-strongly connected component descendants. And I can see inside here that we've got two nested loops, and inside the nested loops, if some conditions are true, we're going to return a Boolean. And if we don't make it through and return that Boolean at the end, we're going to return a different Boolean. So anytime something like this happens, this is a place where we can do some refactoring and use some of Python's really powerful iteration tools, specifically the any function and the all function in combination. So before I start to do some refactoring on that, I'm going to just delete some of the comments here. A couple of these things are a little bit obvious and kind of not necessary. So checking each ancestor of W and V, we can kind of delete that. I noticed that this ancestors of V thing is only assigned and then iterated over directly, so I can reduce that directly. This SCC of V is only used once, even though it does save us a couple assignments because we're doing an iteration. I think it makes it a lot simpler if we just put that directly into the code. Now we've reduced this a lot more. We don't need this comment right here. Now there's two if statements that are sort of nested on top of each other, and one happens successively in the other one, which means we can put them together into an and. And this still accomplishes the same thing. Then we can just do a little bit of de-indenting. I'm going to change where the comment is. All right, good. So we're in the situation where we have two nested loops, and then we have an if statement. So we can basically roll these all together, and we can roll them into a single loop. And so if the thing is true, we want to return false, which means that well, let's flip that around. So if it's not true, well, okay, let's return. So if any time this is true, then we're going to return false. So that means we're going to return not any. And then we're going to take the loop, we're going to unroll it inside as an iterator. And then we're going to take that if statement itself, but not the condition, not the whole statement, just the condition, and we're going to put that there. So we basically combine all of that into one place. I would say this is much more easy to understand. I would also probably change some of these comments. So I would, rather than saying SCC, I would write component. Even though that's a little bit less specific, it's a little bit easier to understand. All right, now to make sure that this logic is correct, we're going to run the tests. And we see the tests are passing. So that's good. So we've reduced this like very complicated, nested, jagged structure of ifs and conditionals and control flow into just a single loop. It's a nested loop, but it's, I would say, much easier to understand. Okay, that's one. Second function. Similar thing going on. We've got a for loop, we've got some skipping, we've got some other iteration going on. And in the end, we have two levels of iteration. Again, one of these returns. So here, there's a couple parts going on with assignment. And when this happens, I think it might be nice to take this assignment and put it into an auxiliary function. So what I would do, we're going to give a better name to this later, but I'm going to call it helper. And I want to put the part where we assign the positions, and then we get the min and the max position, and then we iterate over the range of these all into the loop. All into the helper function, because these don't get used anywhere else. And let's say for now, we're just going to yield from this iterator. So we're going to be able to run this in place of this range. We need to pass the candidate order and the SCC, but that means that we can replace the position, the max, min, and this range with our helper. Candidate order, SCC. Okay. I'm going to delete some of the comments. I'm also going to do the same trick as before. You see we're assigning a variable and then just using it directly. I'm going to put that in there. And you can see we're now in the same scenario we were before, where we have a for loop, and then we have another for loop, and if some condition is true, we're going to return false. So this means that if any of the times we're iterating through here is true, then we want to return false, which means that, again, we're going to do this construction, return not any. And we're going to use the same things as before. We're going to start by doing the for loop, and then we're going to do this if check. So if this is true, then we want to continue, which means if the opposite condition is true, then we want to not continue. So I'm going to switch it from less than equal to greater than, and then we can delete this, and then we can use the same thing as below. We can do for pause in helper, and then we can do the if statement. And oh, actually, no, we don't have to do the if statement there. We make the if statement the value inside the loop itself. Okay, and then we're done. We don't have to do that return true at the end. This is in some ways much nicer. Another way that this could be done is also to include this range to have it automatically index from the position. So we could do for pause in range and then yield candidate order pause. And then rather than this being pause, this would be some node, not an SCC. Maybe this is more readable. So iterate nodes. Great. So let's check, make sure we didn't break anything. We're going to run our tests and look, our tests pass. So now we've basically turned that very, very complicated bit of logic into something a little bit simpler, where we can read it like an English sentence. You know, return not if any for the nodes in the components, for all the components. Okay, let's rename these. This is really hard to read. Component in components. So for every component in the components that is, you know, not a single member component, we're going to iterate over the nodes in that component. Maybe we need a better name for this. Find where each node in the SCC, the first and the last occurrence. So actually, as somebody just reading, it's not quite clear why we're doing it this way, but okay, that's making it hard for me to rename this, but at least the logic is still working the same. And now I think this is a little bit easier to reason over, even though it's maybe not possible to understand what's the reason for doing it this way. I think this is still nicer code that's easier to work with. So that's the screencast. We did just check that all the tests pass. I'm going to quickly come into our terminal and run rough and make sure we reformat everything before I make any commits. Now I'm going to come back to my GitHub desktop and I can commit. So all these refactors. So refactor, why not ioSCM utils. Okay, that's it. Thanks.